This video is for Chapter 9, Section 9.1 for the math activity Extending Tile Patterns. We'll use algebraic thinking to identify and extend patterns in color tile sequences. Algebraic thinking is an important foundational skill before children get to algebra. So this really gives you good practice in thinking about how to encourage and nurture algebraic thinking. We have a sequence of tile figures here, and the first step is to build the fourth and fifth figures. This should help you think about how those tile figures are constructed. Then in part A, we talk about describing the number of tiles in the figures. The number of tiles in figure 1 might be described as 2 plus 1 plus 2. Then in figure 2, 3 plus 2 plus 3. Then in figure 3, 4 plus 3 plus 4. And we would like you to find and record two other number patterns to describe the number of tiles. For a little assistance with this, I have marked up the color tile sequence here so you can see where these numbers came from. So for 2 plus 1 plus 2, you can see we have 2, 2, and then 1 at the top. And then for 3 plus 2 plus 3, you can see the 3, then the 2 at the top, then the 3, and then the 4 and the 3 and the 4. Notice I can verbally describe this as the figure number plus 1, so that's the vertical part, plus the figure number, that's the top part, and then plus the figure number plus 1, that's the other vertical part. In part B, use your number patterns and determine the number of tiles in the 10th figure and the 20th figure. And in part C, answer the question, which figure will contain 128 tiles? And of course, explain your thinking. Then finally, in part D, we ask you to write a description of the nth color tile figure in this sequence so that someone reading it could build the figure if they didn't know what the picture and the tiles already looked like. So you want to use your number pattern, and our thoughts on figure numbers before should be very helpful here, because instead of figure number now you'll have n. In question 2, we have a different type of color tile sequence. This one's made of yellow and red tiles. And again, think about how this is built and build the fourth and fifth figures. And then find and record two number patterns to describe the red and yellow tiles. Here I've separated the yellow and red tiles out, and I've marked the yellow tiles in the top and just have the red tiles in the bottom. So you can see, let's start with figure 2, that at the top I have 2, then 1, then 2, 1 on the sides, each side, and then on the bottom 2, then 1, then 2. Of course 2 is our figure number. Then here for figure 3, I have 3, then 1, then 3, top and bottom, and of course 3 is our figure number. And my side is now 2. One way to think about 2 is that it's 1 less than the figure number 3. And then you can match the number patterns that you are thinking about back to figure 1. When you look at the red tiles, notice that these are rectangles, and a nice way to think about rectangles is to think about the dimensions. This is 1 high, this is 2 high. Over here in figure 1, there's actually a 0 high red tile middle. Then in part B, use one of the number patterns you've determined to describe the number of red tiles and the number of yellow tiles in the 10th and the 20th figures. Then in part C, write a description of the nth color tile figure, so again, someone reading it could build the figure. And then finally, describe your colored tile sequence in terms of n. So if you have an arbitrary figure number, you know how many tiles there are in it. That's it for Math Activity 9.1. I hope you have fun developing algebraic thinking and thinking about extending tile patterns.